Dear children, we have already studied about atomic radii, ionic radii and their trends along a period and a group. The next property which we will study is ionization energy, also known as ionization enthalpy. When there is a neutral atom, the number of the protons is equals to the number of electron. But when a cation is formed, an outermost electron is removed or pulled out against the effective nuclear charge. And when we do so, we need energy because we are pulling out the electron against the nuclear charge. This amount of energy is known as ionization energy or ionization enthalpy. Let's define. Ionization energy is the energy required to remove one outer electron from an isolated gaseous atom in its ground state. X is the neutral atom in the gaseous state. We are removing one electron and X is changing into X plus, that is a cation. Unit of the ionization energy is kilojoules per mole. If we want to remove one more electron, then that ionization energy is known as second ionization energy, and when we removed first electron, that is known as ionization energy 1 or first ionization energy. Ionization energy is always positive because we always need energy to remove the electron. Ionization 3, that means the third ionization energy. What is this third ionization energy? It is the energy required when we are going to remove or pull out the third electron. The third ionization energy is greater than the second ionization energy and second is greater than the first ionization energy. The reason behind is when we removed the first electron, the atom was neutral and it was in the ground state. So, we need a lesser amount of energy. But when we remove the second electron, now it is not a neutral atom, rather it is a cation. Already more protons are holding the lesser number of electrons. So, effective nuclear charge is high, and against that high effective nuclear charge, we are removing the second electron. And when we pull the third electron, now it has 2 positive charge. The number of the proton is same and they are holding much lesser number of electrons. So, now I hope that you can clearly understand that why third ionization energy is more than second and second is more than first. Noble gases have maximum ionization energy. The noble gases have their complete octet. They are in the most stable state. They have 8 electrons in their outermost shell. So, when we are going to disturb this outermost stable configuration, obviously we need much higher energy. The alkali metals have minimum or the lowest ionization enthalpy. The reason is each alkali metal has the largest atomic radii in their respective periods. Also, they have only one electron in their valence shell. So, their ionization enthalpy is lowest. Ionization enthalpy trends. First of all, along a group. When we study a group, we always talk about top to bottom. Ionization enthalpy decreases down the group. The reason is the atomic radii is increasing when we move from top to bottom, and when the size is increasing, it means that the valence electron is moving away from the nuclear pull. So, it will be very easy, or you can say that we need very less amount of energy to remove that valence electron down the group. Let me revise it again. It is due to atomic radii increases down the group, outermost electron being increasingly farther from the nucleus. Increased shielding effect. Increased shielding effect means when the size is increasing down the group, the inner shells, they behave as a wall, a screen between the nucleus and the valence shell. So, it becomes very easy to remove the valence electron. Penetration effect. The s orbital has the highest or the maximum penetration effect, and then it is in the order S, P, D and F. F has the minimum penetration effect. It means that the nucleus has the strongest effect on the s orbital electrons. So, if we are removing the electron which is present in the s orbital, we need higher energy as compared to that electron which is present in the p orbital or a d orbital. It also affects the value of the energy required, that is the ionization enthalpy. For example, the ionization energy of the boron is less than the ionization energy of the beryllium, because in the beryllium we are pulling out the electron that is present in the 2s orbital, whereas in the case of the boron, the electron which is to be removed is in the 2p orbital. No doubt, the value of the principal quantum number is same in both the cases, 2p and 2s, but the penetration effect of the s orbital is higher. The next thing which affects the ionization enthalpy is that if you are going to disturb the stable electronic configuration, that is either it is half filled or full filled, it will need higher, much higher energy. For example, we can compare the ionization enthalpy of oxygen and nitrogen. Electronic configuration of nitrogen is 1s2, 2s2, 2p3. p3 means it is half filled, extra stable. Oxygen electronic configuration is 1s2, 2s2, 2p4. 2p4 is not as stable as the nitrogen electronic configuration. So, when you pull out the electron, in the case of the nitrogen, you need higher energy as compared to the oxygen. We can compare that the 2p orbital is in both the cases, but in the case of nitrogen, it is half filled. Electron gain enthalpy and electronegativity. Electron gain enthalpy. When an anion is formed, we add an extra electron in the valence shell. When we add an extra electron in the valence shell, the energy is released. This is known as electron gain enthalpy. Let me define. It is the enthalpy change accompanying the process when an electron is added to a gaseous atom to convert it into a negative ion. A negative ion is an anion. Enthalpy change or the energy change means there are the chances when the energy can be needed to add the extra electron, that is in the case of the noble gases, because their octet is complete, and when we add an extra electron, the incoming electron experiences the inter-electronic repulsion. At that time, we have to supply energy to add that valence electron. Otherwise, the energy is released in the case of electron gain enthalpy. X is in the gaseous state and we are adding an extra electron and it is changing into X with one negative charge, that is an ion. Electron gain enthalpy can be exothermic or endothermic, as I have explained you earlier. Group 17 elements have very high electron gain enthalpy, but here we have to give stress on the point that the electron gain enthalpy of chlorine is higher than the electron gain enthalpy of fluorine, in spite of the fact that fluorine is the maximum electronegative element of the periodic table. The reason is that in fluorine and in chlorine both have 7 electrons in their valence shell, but the atomic radii of the fluorine is smaller as compared to the chlorine. So, the incoming electron experiences higher repulsion in case of fluorine, and in the case of the chlorine they are accommodated very well because the size is large and incoming electron experiences the less interelectronic repulsion. Same is the case with oxygen and the sulfur lying just below it. It is difficult to remove an electron due to a small size or high effective nuclear charge, so it will be also easy to add a new one. Noble gases do not follow the trend in electron affinity because a filled valence shell makes it energetically unfavorable to add an electron. Electron gain enthalpy trends, trend along a period and along a group. First of all, across a period. Electron gain enthalpy increases across a period. It is because of the decrease in the atomic radii from left to right in a period. When the size decreases, it is difficult to add the electron. And effective nuclear charge increases, so it is easier to add electron to a smaller atom. Along a group, electron gain enthalpy decreases from top to bottom because the atomic radii increases. For example, electron gain enthalpy of fluorine is less than electron gain enthalpy of chlorine. It is only due to the change or the increase in the size of the shell, as in the case of the chlorine the size is larger than fluorine. The next and the last property is electronegativity. Electronegativity is the tendency of an atom to attract the shared pair of electron towards itself when it is in the bonded state. It is a very general property and it cannot be measured. An element can have a different value of electronegativity depending upon with which element it is bonded. It cannot be measured, it is a general tendency. Electronegativity describes how electrons are shared in a compound. You can see from the picture HCl. The bond is between hydrogen and chlorine. Chlorine is more electronegative as compared to hydrogen. So, the electron cloud, the shared electron cloud is more shifted towards chlorine, and the chlorine acquires slight or partial negative charge and hydrogen acquires partial positive charge. Whereas, in the case of the hydrogen molecule, since the shared pair of electron is lying between the two similar atoms, the shared pair of electron is exactly in between the two hydrogen atoms and there is no charge created. It is not a measurable quantity. Fluorine has the maximum electronegativity. Electronegativity increases across a period from left to right and it decreases down the group from top to bottom. Again, reason behind is the variation of the atomic radii. It is due to, as the atomic radii increases, electronegativity decreases because the attraction between the valence electron and the nucleus increases. Let me give you the quick recap of the trends of atomic radii, ionization enthalpy and electron gain enthalpy. From the picture you can see that the size, that is the atomic size, it is increasing down the group and it decreases across a period from left to right. You can see the head of the arrow pointing towards the left hand side, that is towards the first two groups. This shows that they have larger size as compared to the p block elements. Ionization energy, it increases across a period from left to right and it decreases down the group. Electron affinity, it also increases across a period but it decreases down the group. The larger which is written is The arrows you can see in the ionization energy and electron affinity are pointing in upward direction. That means the value of the ionization energy of the top elements is larger as compared to the bottom. That is why we say that ionization energy decreases down the group and electron affinity or electron gain enthalpy decreases down the group. I hope all these properties and their trends are clear to you.